All right. Well, what we're going to do is I have some examples of how inverses are used in a variety of different contexts, composing different inverses together. We're going to find inverses of different functions, dealing with piecewise and other ones. But it's just a variety of different ways of how we can solve inverses, some piecewise, some rational functions, and also how we can graph inverses. So first off, what we have here is how can we find the inverse of an indicated point? Well, here we have a composite of two values. So we have an inverse of g composed of the inverse of g of -8, and that's what we're looking for. So in order to solve this problem first, okay, and find the indicated value, is that we need to first identify what is the inverse of g. Well, up here, we are given two different functions. We are given f and g of x. So what I want to do in order to find this problem is I want to find the inverse of g. So to find that, I'm going to switch my x and y values, and hopefully you know that g of x equals y cubed. All right, so I'm going to switch my x and y values, x and y's, to find inverse, and then I'm going to solve for y, and then solve for y, solve for y. Okay, so when I do that, I get a different color here, x, and we have third. All right, I take the cube root of x, and that equals y, and that is my inverse of g of x. Okay. When we do this now I can use this to help us figure out. So I'm going to substitute in -8 into my inverse of g of x, which is this right here. So using what I know about functions, I'm going to have this right here, which is going to be the cube root of -8. So using a little substitution, all right, we can do that. Now from here, I'm going to simplify this, and we know this is going to be -2. All right, the cube root of -8 is -2. And now I'm going to take the inverse of g of -2. Well, the inverse of g of -2, well, that's going to be the cube root. So I'm going to substitute this into, once again, the inverse of g. And what we have here, we have -2, and the cube root of that is going to equal this right here. I'll move this over here. All right, there we go. And what we have then is this is actually going to equal negative cube root of 2, and that's going to be our indicated value. All right, that wasn't too bad. When we have another one, we're going to try this one right here. Okay. With this one, we're going to need to find the inverse of g, which we already know. Found that right there. And then we need to compose that inverse of g with the inverse of f of 2. Okay. So what is the inverse of f? Because I need to know that first, because I need to plug 2 into there. Well, I have f. I'm going to go smaller so I can put some values there. All right, and now I'm going to find the inverse of this. Now, this is a line. So in order to find this, I'm going to switch my x and y's. I should put that in there. And switch them. Oops, make sure you switch them. All right, and now I'm going to solve for y. So when I solve for y, I'll put that up here. We're going to add a 3 to the other side, and then multiply both sides by 8. And we get y by itself, which is the inverse of x. All right, and I'll simplify this. 8x plus 24, that equals the inverse of. Okay, so that's my inverse of f. So when I go here, I'm going to first find inverse of g. I need to plug in 2 into the inverse of f. So I'm going to plug it into here. So I have 8 times 2 plus 24. And what I have is 16 plus 24. And what I got right there is going to be 30, 40. And now I'm going to have this inverse of g of 40. Well, now I need to use the inverse of g. Well, the inverse of g, once again, is that cube root. So I'm going to take the cube root, actually right over here. This is going to equal the cube root of 40. Well, we know 40, if we want to break this down a little bit farther, 40 is actually 8 times 5. Take the cube root of 8, cube root of 5, and we have 2 cube roots of 5 would be our simplified answer. Okay, so this is using inverse function to find indicated values. Okay, so we have to find inverses and plug them in. Another example that we can find, and this is in our textbook that I have, is that we want to find the inverse of this function. Now, this is a piecewise function. So to find the inverse of this function, the first thing we probably want to do is to see if it does actually exist and find its inverse. So if it does, find the inverse. Okay, so we have this piecewise graph. It's going to be a little bit more tricky, but let's figure this out. Now to figure this out, I'm going to first graph. So graph f, because I want to use the horizontal line test. So to determine this, I want to identify using the horizontal line test. Horizontal line test. So I'm going to graph this piecewise graph. And that's why it's important to know how to graph piecewise functions right here. So we have a line, y-intercept at 3. And actually, I'm just going to plug in some points. All points that are less than or equal to 0. So I'm plugging 0, and I get 3. So 1, 2, 3. And then I'm going to plug in -1. So it's going to be an open circle here. And -1 is going to give me 2. All right. And we have this graph right there. Okay. Those are the values that are less than or equal, less than 0. All right. And so I'm going to have that. Then I'm going to have, for my other graph, all right, I'm going to plug that in there and get 6. 1, 2, 3, 4, 5, 6. It's going to be a closed circle because it can equal. All right. And then I'm going to plug in 1. When I plug in 1, what I have then is 5. 1, 2, 3, 4, 5. At that point, and this is another line, so it goes on like this. Now, if you look at this, and I bring up my handy-dandy horizontal line, here's my horizontal line, and this is a function. However, does it pass the horizontal line test? Well, up here, let's straighten this out a little bit. There we go. Up here, it does pass the horizontal line, but as I get lower, I can see that it hits 2 indicated values. This function is not one-to-one, because it does not pass the horizontal line test. Not one-to-one. What am I writing here? 1-to-1. And therefore, does not have an inverse. F does not have an inverse. So, we've, all right, missed the bullet on that one. All right, so we don't have to figure that one out. Okay? All right, so let's try another one. All right, right here. This one, find the inverse of this function. Now, this function, we're given that it does have an inverse. If we were to graph it, we would see that it passed the horizontal line test, and so on and so forth. But we want to find this inverse f inverse of f. Once again, when you see this, please identify that it is the inverse. All right, it's very similar. All right, a lot of students, when they see that -1, they always think it's a reciprocal. They always try to go like the reciprocal of f of x, and then they would write like 2x plus 6 over 8x minus 4. That is incorrect. All right, I'm sorry that I even wrote that up here. That is not correct. All right, this means inverse. Okay, this little thing is the inverse. Okay, very similar when you have the inverse sine or inverse cosine. That's how you identify an inverse of a function. Functional inverse. So, in order to figure this one out, a little bit tougher one. Okay, well, we're going to switch x and y values. So we have x equals 8y minus 4 over 2y plus 6. We're then going to, all right, get rid of the denominator, because now I want to solve for y. So once we switch x and y's, switch x, y, and then solve for y. To do that, I have x times 2y plus 6 equals 8y minus 4. From here, I'm going to distribute the x through, and I have 2xy plus 6x equals 8y minus 4. From here, what we're going to do is we want to get all the y's and all x's on the other side, so I'll keep this right here. I'll just subtract 8y, and then I'll subtract this 6x to this other side. From here, one of these things is just like the other. What can we factor out? Factor out a y. It's right here. -4 minus 6x. And then we can divide on through the other side. -4, -6x. 2x minus 8. And that, my friends, is going to be our inverse function. Okay? We can simplify this a little bit. We realize that we have a 2. All right? If I wanted to, I could factor out a 2 here. And we have -2 minus 3x. And on the bottom, we can also factor out a 2. So we have 2x minus 4. We can cancel that out. We're left with this simplified response. But that is the inverse of our function. All right. I have one more function on how to sketch. So we went through several examples of how we used inverse functions. We tried to identify with a piecewise function if it had an inverse, and it did not pass the horizontal line test. We also saw whether the rational function, how to do that algebra. The next one we have right here is we want to given a table, okay? Given a table. With this, actually, I think I'm going to stop here and start with the next one. So the next tutorial we'll have on graphing this, our graph of how to find the inverse given this graph.